In this lesson, we're going to talk about how to divide numbers in scientific notation. So here we have our first example, 6 times 10 to the 6th divided by 2 times 10 to the 3rd. Now let's approach this one the same way we did with multiplication and look at it in terms of a regular exponents example. Let's say we had 6a to the 6th divided by 2a to the 3rd. Well, what could we do? Well, first of all, we'd recognize that this was 6 times a to the 6th. It's just two numbers being multiplied together. And this, of course, is 2 times a to the 3rd. And that allows us to group them a little bit more conveniently. So we take our 6 and our 2. We can divide those. And when we divide 6 by 2, we get 3. So we divided our constants. And then when we divide our exponents, you'll remember the rule was we simply subtract those. So we would get 3 times a to the 6th minus 3, or 3a to the 3rd. Now hopefully that looks familiar to you. Let's apply that same process to the problem we have to deal with here in scientific notation, because again, scientific notation is really just working with exponents. Once again, we have two constants here, so we're going to divide those two numbers just like we did over here. 6 divided by 2 is 3. Then we'll divide the 10 to the 6th and the 10 to the 3rd. That's going to give us 10 to the 6th minus 3, or 3 times 10 to the 3rd power. That's all there is to it. Another example, 4.5 times 10 to the 9th divided by 9 times 10 to the 5th. This time we have decimals. Well, it's going to be the same process. We're going to divide the two constants, and then we'll divide the two exponents. So what we'll wind up with is, and I'll write them on top of each other like you're familiar seeing them, 4.5 times 10 to the 9th over 9 times 10 to the 5th. So the first thing that we will do is we're going to divide our two constants here. So let's do that up here. 4.5 divided by 9. So I'll wind up with 0.5. 0.5 times 10 to the what? Well, times 10, and we subtract our exponents to the 9 minus 5. So we get 0.5 times 10 to the 4th. But is this in proper scientific notation? No, it's not. That means we have to adjust it. We're going to have to move our decimal point one space to the right to get our proper scientific notation, right? So it looks like your number, your decimal, any of your significant digits times 10 to the something power. So when we move that to the right, that's going to give us 5. And we have to adjust our exponent on our 10. So that would give us 5 times 10 to the what? Well, since we had to move our decimal to the right, we're going to decrease this number. So that's 5 times 10 to the 3rd. In your homework for this lesson, we also deal with some situations where we're multiplying and dividing together. Let's take a look at that and use some negative exponents at the same time. In this problem, we're going to have two steps. We have two numbers being multiplied together, and then we're also dividing by 3 times 10 to the negative 2nd. So our first step will be to deal with what's on top of your fraction bar, and then divide that by what's on the bottom. So let's do that. We'll take 7.3 times 10 to the negative 11th, and we'll multiply that by 1.2 times 10 to the 15th. That's easy enough. So we'll get 8.76 times 10 to the what? Well, we've got to add our exponents. So negative 11 plus 15 is going to give us a positive 4. Then all we have to do is divide that by our number here on the bottom. 3 times 10 to the negative 2nd. All right, again, we're going to first divide our numbers over here. So we'll take 3 into 8.76, 2.92, times 10 to the what? Well, we've got to subtract our decimals. So 4 minus negative 2. And remember, when we subtract, we're really just adding the opposite. So we're going to get 2.92 times 10 to the 4, and then we're going to make this, in our mind, addition and add the opposite. So 4 plus 2, which is 6. 2.92 times 10 to the 6th This is indeed in scientific notation. You're done.